You see problem 1, practical kinematic tools, and you see two planes, A and B, and they flying on the same altitude. The velocity of VA as shown on the finger, 600 kilometers per hour, and the direction of VB also shown in the finger, VB at 500 kilometers per hour, and the angle theta here 75 degrees. And the question asks what is the velocity of plane B, velocity keyword, right, B with respect to plane A. So basically this is a relative velocity equation, relative velocity motion. So with that we have to use relative velocity equation, and B relative to A, so we start with VB equal to VA plus VB relative to A, because the question asks B relative to A. If they ask A relative to B, then you start with VA, then equal to VB plus VA relative to B. And in the note, we're talking about how to solve the vector equation, either relative velocity equation or relative acceleration equation. In this case, relative velocity equation, we can use either of the graphically method or resolving into components x and y, and then use scalar equation, two scalar equation to solve. So for the first method, which is for this video, I use graphical, and we only want to demonstrate how to use graphical method to solve the problem only for problem 1 only. From now on, after this, you use components and scalar equation to solve for all other problems. So this problem, just for demonstrative purposes, I use graphical solution, graphical method in here. So from that, as you can see, VB, VA plus VB relative to A. And with that, I can rewrite that equation as VB relative to A equal to, I kick VA to the other side. So I have it VB minus VAs, Or I can write VB plus negative VA. And as the method implies, use graphical, so we can draw something, right? Draw graphic. So let's draw that. Here we have two vector A and B, two vector A and B. VA, so we have VA, two vector VA and VB. So VB there, and it's 5 kilometers per hour. Sorry, 500 kilometers per hour airplane. And then we have negative VAs, and you can see VA going down here, VA. Then negative VAs have to be go up opposite direction, collinear of VA but opposite. So I can write that one here. Let's change the color so that it will be negative VA, and the magnitude is still the same. As you can see, it's still 600 kilometers per hour. And as we know, because the equation vector VB relative to A vector equal to VB plus negative VA, so geographic, I can have parallelogram, the diagonal line, it will be the resultant of those two vectors VB plus negative VA. So in that one here, exactly that what we are looking for. Velocity of plane B relative to plane A. So at a vector, one vector have two unknowns as we already talking about. The first is the magnitude and the other one is the direction. So we need to find both. So let's continue something that we haven't used in this information, that the angle theta here. Angle theta is 75 degrees. 75 degree. At that angle 75 degree, we can have the angles here are equal to 180 straight line minus 75, 105 degree. And as 105 degree here, I can have 105 degree in that angles. And at 600 kilometer per hour, we also have the opposite here, 600 kilometer per hour on this side. Okay, so now we may be able to use cosine law to solve this problem. For example, magnitude of VBA, we did the opposite, so we use cosine law. So review cosine law. So let's write down, recall cosine law. So the opposite square, VB relative to A square, as you can see, VB relative to A square is equal to the two other sides square, so it will be equal to VB square plus negative VA, because that side, the other side, VA negative square, minus 2 product of the two sides, VB times negative VA, because the other side negative VA, and then cosine of the opposite angle. So we work on the VB relative to A. The opposite angle is 105 degrees. 105 degree. So from that, we plug in, we can have, and then square root. So we have VB relative to A equal to square root of that, and all about magnitude, because we talk about graphics, so the distance. So put all positive in. VB 500 square plus negative VA. So magnitude again is 600 square minus 2 times 500 times 600 times cosine 105 degree, and from that we can have the magnitude BA. Magnitude BA equal to magnitude BA equal to 875 kilometer per hour. Kilometer per hour, not mile per hour. Kilometer per hour. So that is the magnitude. That is the magnitude. We also want to know the direction. So let's call the angle here alpha. Angle here is alpha. How can we do the alpha? We can recall sine law. Recall sine law for the triangles. So what do we have? The opposite side over the side of the angles, it will be constant. So what does that mean? We have opposite side of the 105, it will be VB relative to A. Opposite side of angle alpha, which we want to find out the direction of VB relative to A, it will be 600 kilometer per hour. So what does that mean? If we have 600 kilometer per hour over sine alpha is equal to VB relative to A, 8 VB relative to A, and you can see there. So 875 divided by sine 105 degrees. So one equation, one unknowns, you can inverse tangent. So from here, I can have alpha equal to inverse sine, equal to 600 times sine 105 degree divided by 875. From that we can have alpha equal to 41.5 degree. 41.5 degrees. So from that, what can I say the velocity? What it should be the answer? As you can see, the magnitude is 75 kilometers per hour. The angle alpha, 41.5 degrees from the negative x-axis. So you can say the velocity, you can answer velocity B relative to A, plan B relative to A equal to, same as you do in 2D forces at very first few lesson of our class statics. You have it A 75 kilometer per hour at 41.5 degree. In this case, as you can see, from the negative axis, so it will be go that way, so it will be clockwise, right? So clockwise 41.5 degree from negative, and in this case we assume negative x-axis go to the left, negative x-axis. So one vector, we have to determine both magnitude, of course have unit, and direction. With that, we can graphically solve this problem. And the next solution, you will see how we use components and scalar equations.